Hello students, welcome back. In the previous video we have already seen how a rational number is transformed into a decimal form. Right? For example, we have taken 1 by 2, which is nothing but 0.5. This is a rational form and this is a decimal form. In this video we will try to learn what steps are involved to change a rational form into a decimal form. This is a small chart which shows the steps involved in doing this process. We'll take one example and we'll try to follow this procedure to get the decimal form of the rational number. For example, let us take a smaller number, that is 23 upon 8. This is a rational number, P by Q form, right, where Q is not equal to 0. We'll apply this procedure to get decimal form of this number. What is the first step? The first step says divide the numerator by the denominator. So we will take the numerator, which is 23, okay, by the denominator. So denominator here is upon 8. The second step says continue the division till the remainder left is less than the divisor. So we will try to divide this, okay. So 8 times what is closer number to 23. So 8 2s is 16, right? 8 2s is 16. 8 3s is 24. So we cannot take 8 3s are 24. Now if we subtract 23 minus 16, 7, right? Now here we got which is less than the divisor. 7 is less than the divisor. Yes or not? Yes. 7 is less than the divisor, which is 8. Now go to step 3. Now what it says? It says that put a decimal point in the dividend and at the end of the quotient. So we'll try to do that. Decimal point in the dividend. So we'll put a decimal point in the dividend. As you know, this is the dividend. And at the end of the quotient. So here also we should keep a decimal point in the quotient. That is the step 3. So what we have done? First step, we have written the numerator in the middle and denominator to the left side, which is divisor. Then we did 8 2 is 16. 8 twice of 8 is 16. Then after subtraction we got 7. Then the third step says that put a decimal point in the dividend and in the quotient. Let's proceed to next. Step 4. Put a 0 on the right of the decimal point in the dividend as well as the right of the remainder. So it says that you have to put a decimal in the right, to the right side of the dividend and to the right side of the what? Remainder. So here as well. So now 7 became 70. So now in what times of 8 is a number closer to 70? 8 7s is 56, 8 8 64, 8 9 72. So can we take 72? No. So 8 8s is 64. Now again we will do subtraction. 70 minus 64. We'll take the remaining as usual, borrow. 0 minus 4. We cannot do that. So 7 becomes 6. 0 becomes 10. 10 minus 4 is 6. Right? 6 minus 6 is 0. So now we got 6. What is the step 5? The step 5 says repeat step 4 till either the remainder is 0 or the requisite number of decimal places have been obtained. So we will try to divide this till our decimal number ends, or we will have a required number of decimal places. So we'll continue the process. So point 0 we have kept here, 0 here. 8 7s is 56. Do subtraction, you will get 4. One more 0, 0 here. 8 5s, 40. Now if you do subtraction, you will get the remainder as 0. So we got 23 upon 8 as 2.875. After continuing this process, we have got 2.875. This is nothing but the decimal form of this rational number.
Let's take some more examples. As you can see in the slide, we can clearly observe that there are only finite number of digits, means countable number of digits in the decimal part of these decimal numbers. Such decimal numbers are known as terminating decimals. Terminating decimals are those decimals which have the division process terminating at some point. The word terminate itself means to stop or to come to an end. Now observe this division. As you can see, the division is never coming to an end, and the remainder is starting to repeat itself after some steps. Such decimals are called non-terminating repeating decimals or non-terminating recurring decimals. Recurring or repeating means the same. If there is no repeating pattern and the division is going on without ending anywhere, then the decimals are known as non-terminating, non-recurring decimals, which you will learn in the later classes more in detail. The digits repeated are shown under a bar, as you can see in the slide. The bar here indicates the number of digits which are repeated in that decimal. Here are some more examples.
This is your worksheet. I hope you will be doing this. The first one says express the following in decimal form. You have some rational numbers. You have to do the division process what we have followed, and you have to express it in decimal forms. And the second one is even simpler. The following decimals in correct place. I have given 8 decimals. So this you have to put it into each place. For example, this is terminating and non-terminating table. First one, this is terminating or not. If it is terminating, you have to put in this box. If it is non-terminating, you have to put in this box. This is your homework, a small homework, okay, so that it will be a practice for you all. So next time we will see it in the next video. Thank you.